Okay, trigonometric identities. In calculus, we need to know these basic identities because it makes our calculus a little bit easier as you go through the class. So let's look at what an identity is first. So let's say that we have two functions. Okay, remember, you need to know what a function is, by the way. A function is for every input, you get exactly one output. So let's kind of put a note on that. So, for every input, you get one output. So for every input, you get one output. So if I put an X, what I get out of the system, if I put that in there, I get a Y. So that's what a function is. But we're going to say, okay, we have two functions. Okay, so two functions, let's call them f and x, and we have, let's say, g of x. So these are two different functions. What we're going to do for an identity, though, we're going to say, well, why don't we take our functions and make them equal? So we're going to make them equal. Well, what does that specify? Well, that specifies that we have what we call an equation. We have a balancing scale here. We have an equation with an equal sign. And that says if I put an x in, that should x be the same thing on the outside. So if I put an x, it should equal to that. So here's kind of what I'm trying to say here. So if I put an x in here, that gives me an output of f. If I put an x here, well, the same x, I'm going to get f equals g. That's kind of what an identity is. And here's some examples of some identities. So let's say 1 obviously equal to 1. We know that. That's an identity. Another identity, well, what if I had x plus y? Well, that is also x plus y. So those are just basic identities that I kind of want you to kind of have under your skin when we do this. But there is other ones. Well, we're doing trigonometric identities. So trigonometric. So we gotta have some trigonometric stuff here. So let's start off with some basics. So let's do this. What if we start with a unit circle? So start with a unit circle. Here we go. Here's our unit circle. And we're going to say, okay, here's a point on that unit circle. And we're going to extend that point, go down, and that point is going to be x comma y on the unit circle. So let's do unit circle. We have a point on the unit circle, x comma y. Well, we got to make some notes here that x is equal to the cosine of whatever theta is. So whatever this theta is, we're going to say, okay, that is, the x is the cosine of that theta. Well, we can say that with sine. We can say y is actually equal to the sine of whatever theta, call this theta, I guess, whatever theta that is. Okay, we have a unit circle. We have x equals cosine of theta, y equals sine of that theta. Well, that is something that we need to kind of take away from this. So let's develop our trigonometric identities. So our trigonometric identities, remember, do you know what, remember the unit circle? Well, this right here is what we call a circle centered at the origin. This is a circle centered at the origin. So if we draw a circle, do this, this is x, this is y. This right here is 0, 0. So this is a circle, a standard circle equation centered at the origin. Well, from this basic equation, we already said that x equals cosine and y equals sine. Well, let's take this idea and plug those into here. So if x is cosine, we can say, okay, well, that's cosine maybe theta squared plus sine, sine theta squared equals r squared. Okay, and that kind of just saying, okay, well, we have cosine squared, sine squared equals r squared. Well, there's another way to rewrite this. Well, here's what we're going to do. We're going to take this, be cosine squared theta plus sine squared theta equals r squared. All right, well, we're going to kind of look at this a little bit. We're going to look at this last part. We know that this is a unit circle so a unit circle, and we know we have a radius of 1. So let's take this idea and put it in for r. Well, that's going to be cosine theta plus sine squared theta equals 1. This is what we call an identity. This is one of your first identities that you really need to have under your belt if you're going to take a calc class. Now, we can get 2 other equations or identities from this, and that's kind of what we're going to try to do in a little bit. So I'm just going to write them down, and if you kind of do this, if you kind of divide these by cosine, so I'm going to kind of run through this here. And if we do this like this, and what if I take this and divide by this time cosine? What if I take this one and divide by cosine, and then just keep going and divide by cosine? And what that's saying, if I divide by cosine squared theta, the whole thing, well, this is just going to be 1. And this is going to be sine over cosine. Well, that's just tangent. Well, what is 1 over cosine? 1 over cosine is going to be, I think it's secant. Yeah, so secant theta squared. So there's the other one. All right, so here's 1, here's 2. Well, how do we get the next one? Well, we're going to take the same thing. Let me just rewrite this because I think this will help you. And let's take this one now and divide this by sine theta, and sine theta. And let's look at this one. Oh, cosine over sine. I think I know what that is. I think that's cotangent. Yeah, cotangent. Well, this is just going to be 1. And this is going to be cosecant or cotangent. And here's the next one. So there's your 3 that you really need to have under your belt. And I'm hoping that you're seeing that these are equations. And you can rearrange these equations to make them still equal each other. Here's what I mean by that. If I take this tangent squared and move it over here, well, that means that this side is going to be secant squared theta minus tangent squared theta equals 1. And you can do that with all of these. Okay? So let's kind of do some basic stuff. So let's start proving these a little bit. Now, when I say prove or proven identities, you are trying to kind of write an equal sign below here. You're kind of making this side equals to this side, or this side equals to that side. You're trying to make it equal. So you're kind of putting a little question mark. How can I take this side and make it look like this, or this side and look like this? Why do you want to start proving identities? Because these are very valuable, especially these right here. These 3 ones are very valuable for a calculus class to make things a little bit easier as you confront calculus. So let's work on a couple, kind of get some ideas of what these look like and go from there. So here's one identity that I would like us to prove. All right, so this is say secant x minus tangent x times sine x, does that equal 1 over secant x? Does that? So that's the question mark. Does that? Well, when you're proving identities, you gotta kind of start somewhere, obviously. I've always kind of thought about this. This requires you to do more work than this one. So I'm going to start here. So I'm going to start, I guess, the left side. And we can call this the right side if you want. So let's start on the left side. And let's kind of manipulate this a little bit, maybe kind of break this down to make it look very similar or exact to this. So let's work on the left side as we are. So here's kind of the idea here. We have a tangent. We have sine. Why don't we take tangent and rewrite it as sine and cosine? And let's do the same thing with secant. So let's go 1 over cosine. So that's that. Minus, well, let's break this down a little bit. So let's go sine of x, cosine of x, right? Because sine over cosine is tangent. And times this by sine. So that's kind of what I did there. I just broke stuff down into sines and cosines. So I took tangent and broke it down to sines and cosines. Well, does that help me out? Yeah, it's a trick. It might help you out. Yeah. Okay, so I'm thinking, okay, I have a fraction. I have two fractions here. I have a common denominator. So, I can actually do some work here. Oh, this is easy. So if I put an equal sign and make this into one fraction, because I have a fraction, I can fraction. I can make this into 1 because I have a common denominator. So let's put this into one fraction. So that's going to be 1 minus, well, what is sine times sine? Isn't that going to be sine squared x? Yes. Well, okay, awesome. Well, that kind of makes it look a little bit better. It doesn't have all that other stuff in there, so we're trying to make it look like the right side. Are we getting close? Yes, we are. Okay, now we have to kind of think about this. What if I take this part right here and kind of put a little asterisk, and I'm thinking about, have I seen an identity like that? Have I seen an identity that has 1 and sine squared in it? So I'm going to look back. I'm thinking, I like this one. I like this one because I see the sine, I see the 1. What if I subtract? Well, let's see. What if I subtract sine squared theta over on this side? Oh, I get a cosine squared. So if I subtract this over here, I get cosine squared theta. Well, that's what you want. So this part right here is going to go cosine squared x because that's your identity. Well, on the bottom, you have just cosine x. Well, according to fractions, I have a 2 and I have I guess a 1 there. Well, doesn't one of those cancel out? So you have on the top, don't you have cosine x over 1? But what is cosine x over 1? Well, that gives me 1 over secant x. Hey, I did it. I just proved my first identity by using one of my known identities. And that's kind of what you're trying to accomplish here. You really need to understand and know these basic identities because they're going to help you through that. That just made your life a little bit easier when you try to break these down. Okay, so let's try this one. This one looks terrible. We might need some more paper on this one. Let's see how it goes. And that's okay. We can kind of do that. So what I want to do is kind of think about this. Remember, you have the left side and you have the right side to deal with. You want to make this equal. Try to. Well, what side do you want to work with? Well, looks like the left is a little bit more cumbersome than the right because the right looks like an identity, and I can rewrite that identity, but that's pretty much all I can do. So let's start on the left, the basic app, all right? So the first thing I might want to do is I'm looking at tangents and cotangents, and I have a sign up here. Maybe I want to rewrite these as cosines and sines because sine and cosine are very like they go together. They're like brothers or sisters or however you want to say, like siblings if you want to say it that way. So let's rewrite this all in sine and cosines. That might help. It might. So I know what secant is. Isn't that 1 over cosine? I know what that is. Times, I'm going to write this as a fraction because I think that will help you because we're kind of doing just the top right now. We're kind of just doing the top. The top looks like that. Okay, now I'm going to kind of look at the bottom. I have tangent, which is sine and cosine, and this is just its opposite. That's just its opposite. Now, what I could do, I could rewrite this, or I can just leave them. And why do I want to do that? Well, what if I just left this real quick? What if I just left this? I'm just going to leave that. And we're going to see why in a minute. We could rewrite it as sines and cosines. But since we have tangents, and I'm looking at the numerator as well. I'm thinking of the numerator. I'm thinking of the numerator. Because isn't this multiplication? So isn't this going to be sine times cosine? So the top is just going to be tangent. Isn't that true? Isn't the top just going to be tangent? Okay, well, I'm thinking about this. They don't have to do all the sine and cosine stuff. And on the bottom, I have tangent plus cotangent. Okay. Well, I'm thinking about this. Could these cancel? No, do not cancel those out. Do not cancel those out. You can't do that. Only with multiplication. All right, let's keep on going here. So we're thinking, what can we do? Well, you know what? I don't know what else we can do, so let's just keep going. Let's just rewrite it as sines and cosines, and maybe that will help. So on the top, maybe I'm going to leave it as tangent just for now. On the bottom, I'm going to have to do it. Let's just do it. So sine and cosine, just going to have to do it. Plus, okay, I know this is going to be cosine and sine. I'm just going to do it and see what happens. Okay. Now you're thinking, okay, I'm going to look at the denominator here. I'm thinking, what can I do here? Well, I have two fractions. I guess maybe we can we combine these bottom fractions? And the answer is yes. Let's combine the fractions. So on the bottom, so just the bottom here, let's combine these fractions. And I don't know how you learned how to combine fractions, but it's pretty straightforward. And I can show you if you like. So let me show you this. You don't have to do this part if you don't want to. You can skip this over. But I'm going to have to kind of multiply these two. So that's going to be sine times that all over. See if I multiply those, those are going to be cosine that. Cosine x all over sine x cosine x. I'm just trying to get a common denominator, everyone. So this part up here. If I multiply this times this times this, isn't this going to be sine x or sine squared x? Well, what's this going to be? Well, that's going to be cosine times cosine, which is cosine x squared, all over the denominator, which is just this simple thing. Okay, so there you go. Well, as we did the denominator, remember, okay, we haven't touched the numerator. This, I guess, if you want to, this is still going to be over that tangent x. So this is kind of what we're aiming for now. This is what we're aiming for now. Okay. Well, I'm going to break this down for you because on the top, I still have tangent x. On the bottom, on that bottom fraction, okay, look at this. Oh, sine x squared, cosine x squared. I've seen this before. Wait. I've seen this before. Oh, I've seen this before. That's just 1. Oh, okay. So that's going to be 1 all over. I guess you can just read it like this too. It's just the same thing. Oh, I can rewrite that. Now, I can do a couple more things. I can actually, this is 2 fractions. This is 2 fractions. And if you want to, you can take this and make it a little bit easier to read. So you could go sine x all over cosine x all over 1 over cosine x sine x. And then I have 2 fractions here, so that's keep, change, flip, right? Keep, change, flip. So if I go over and go keep, change, flip. And now, multiply. Straight across. And if you do this, you don't actually have to multiply because you can actually see this. You're going to multiply this and this go bye-bye. That and that go bye-bye. Right now. Well, on the top, I have sine squared over 1. So let's go back to our identity. Let's go back to our original identity. Oh, check. All that work is for there. We just proved that this identity works. Okay. So we kind of did all this work here for one identity. We had to do a little fraction work. We had to do a little bit of identity work, and we did it. I'm really telling you, everyone, that going back to these basic ones are really essential. Because if we did not have these identities, we couldn't even figure this one out. Because we would use, right here is where we would use that identity. Gives you 1. Okay, so hopefully that made a little bit more sense. Let's do maybe 1 more of these, or 2. Well, let's try this one. This one looks a little bit more, I want to say simpler. And I hope you see why. I hope you see kind of why it looks a little bit more simpler. So let's go ahead and put our line. And if you want, put the left, put the right. Terrible looking R. All right. What one to start on? Well, on this one, it really doesn't matter 100%. But sometimes you can get to a place where you get kind of lost. So I'm trying to think, what would be the easier way? So I'm actually going to start on this side again. And here's why. I see cosine, and I say cosine squared and sine squared. I see that this might be an identity. This is an identity. And I don't know if you see that or not. But if you kind of go back to your identities again, which is this one right here, I might can actually do something here. Could I use this one and find this one? Well, if I do this correctly, what if I kind of think about this? I have sine squared in this. What I'm going to do is take this guy right here, and I'm going to go 1 minus sine squared x. Why do you think I want to do that? Because this right here is going to, maybe I want to cancel this one out. So what if I do that and said, okay, I'm just going to rewrite this. Okay, I see this. I'm just going to rewrite this. So this one is that one. minus that one. And I'm thinking, okay, now I have two of these. Oh, wait, I see that. I see two. I see two of these. So this part right here is going to give me 2. So that gives me 1 minus 2 sine of theta x. And guess what? Cha-ching. Got it. When I was starting out, that was really hard for me to conceptualize. But I had to think about, I don't have any, so I don't no cosines on this side. I have no cosines. And that's kind of what I'm trying to aim for. I have no cosines over here. So I'm thinking, what can I do to make this not have any cosines? So that's something you might want to think about. Okay, let's try one more. This one looks a little bit intimidating, but this one's actually kind of fun. In my definition of fun, I guess it's not always yours, but it works. So let's do, so left, right. And I know that these videos I've always been starting on the left, and I'm sorry about that, but you can start on the right as well. I guess always problems are from the left. Whatever. So I'm going to start on the left because there's more to do than the right. So I'm thinking about what should I do here? Well, I'm kind of looking at my identities here. I'm looking at my identities, and I'm thinking about secant. Well, I have secant squared here. Oh, if secant squared theta equals all this, can I use this as my advantage? Can I use this as my advantage? So I'm going to say, okay, on the top, I'm going to rewrite the top. So I'm going to go secant squared x all over tangent. You see why? Because this one right here was tangent. If you move some stuff over, so kind of going aim back to here, if I subtract the 1, I have that. Tangent squared equals that, minus 1. Oh, okay. Well, does that make it any easier? Well, I don't know. Let's do some configuration. If you don't mind, I'm actually going to put a little thing on here so I can use this side too. Let's extend this a little bit. So, what can I do here? I know what secant is. What if I don't know where to start. Okay, what if I break some stuff down? So let's break down secant. I know what secant is. Secant is, let's see what secant is. It's 1 over cosine. So this is going to be 1 over cosine x. On the denominator, do I know what tangent is? Tangent is just sines over cosines. So what if I go sine squared over cosine squared? Okay. Oops. So all I did is I'm just trying something. I'm just kind of seeing, okay, I know what this is. This is going to be sine. This guy right here, I know it's 1 over sine squared. I know that. I'm trying to get to that. So I'm kind of thinking about this, Well, I have 2 fractions. What if I combine them somehow? So divide fractions, you're going to change flip. So I'm going to go cosine squared theta times flip. So that's going to be cosine x squared sine x squared. So I did some division there. Okay, multiplication. Oh, wait. I see cosine squared. So I'm going to go ahead and cancel that out. And there's your answer. Cool. That one actually worked out really well. So that's kind of what you have to do on these. You kind of, make sure you know how to rewrite this. You need to kind of have these basic identities down. I'm seriously, these basic 3 identities down and how to kind of transform them. And that's what I would start to do first, is kind of understanding how do you get to these 3 without doing a whole lot of work, going through the proven identities, and then trying some identities. Sometimes the right might equal the left to a certain situation. So you might have to do a little bit of work on both. Sometimes in a rare case, you might have to work on both to get them to an area where they're going to be equal. That I have seen that before, where you have to kind of work on both to make them actually equal. Yeah, so that's just a rare case. So let's see if that comes up. I don't think it does, but I'm hoping that this video helped, especially with those identities. But I'm thinking that you really need to know that unit circle as well and what an identity is. And I'm hoping that this helps. I will see you on the next one.